If I said that there's a person in Tokyo, can we also assume that this person is in Japan? Well, obviously. As well, would we be correct to assume that this person is also in Asia? Absolutely, since Tokyo is in Japan and because Japan is in Asia. And finally, would it be okay to assume that this person is on Earth? Well, of course, because Earth is even bigger of a set than Asia. Good. Now, there's a whole different set of numbers that is not within any of these. This set of numbers cannot be expressed as a fraction. Another way to describe this is that this set is completely separate from the rational numbers altogether. Fittingly so, we can call these numbers irrational numbers. An example of an irrational number would be pi. And we know that pi is a never-ending number that does not repeat with a constant decimal or in a pattern fashion. And this is what makes it irrational. Square root of 2 also turns out to be an irrational number since it cannot be expressed as a fraction. And lastly, the definition of real numbers is the last classification that we'll talk about. Although there are some other classifications that you might learn later on down the road. Real numbers are simply all of the rational and irrational numbers combined. So pay close attention to how certain number sets are literally in the other sets. But just remember that even though saying that a person in Tokyo must also be in Japan is correct, the reverse isn't always correct. If this person is in Japan, it doesn't necessarily mean that they are in Tokyo. Maybe they're in Osaka or wherever else in Japan. Similarly, while we can say, for example, that all natural numbers are also integers, we cannot say that all integers are natural numbers. The same applies to the rest of the layers of classifications that we've learned. So, the classification of numbers might seem random, but they will be used over and over again, so it'll be well worth your time to learn it thoroughly right away.